Hi, I'm Minghao from the Ectegla Research Group at the University of Alberta. I will present our research towards supporting adaptation, exploring affect's role in cognitive load when using a literacy game. Recent years, study has shown evidence that affect may impact learners' outcome in many ways. For example, positive facts can motivate predictions, negative fact may impair attention and memory. Sometimes some negative effect like confusion may also lead to deeper learning because it may make the learner more vigilant. Although there has been increasing attention to understand how learners affect will react when using different learning environments, it's still really unclear how effects may relate to other concepts of learning involving cognitions. And that includes one important that we will investigate in this study, the cognitive load. Such ambiguity is preventing us to implement a modeling or algorithm to adapt our intelligence system based on learners' effect, and that's the motivation of this study. And it leads us to our first key question: how does the effect can contribute to the prediction of the cognitive load? To answer this question, in this study we conduct a case study where we asked real learners come to our lab and use a game-based learning system for English literacy. And in this system, study is balanced with a base-building game design, where the learner can engage in multiple playing elements that including base construction building and upgrading, training in-game soldiers, and use those soldiers to challenge with other players in competition. And to facilitate the gameplay, learner will need to complete certain literacy practice tasks, and they will read passage and answer the following questions, and instant feedback will be provided after they submitted the answer. Once they got the correct answer, their in-game points will increase, and which can further use to enhance their game's play progress. During their use, the system will keep inferring learners' reading ability based on their learning performance, and continuously address the difficulty level of the passage and the questions. In this case study, we recruited 35 English learners. Because cognitive load is influenced by the individual's working memory capacity, before the case study, we measured this capacity using COSI block tapping test for each participant as an individual difference information. And to capture the experience data, during the study, participants were asked to fill out self-report measures. They measured 3 dimensions. First, we used the IPANAS SF to measure the affect valence. Second, we used SAM, a pictorial scale, to measure the affect activation. And last, we developed scales for cognitive load and its subtypes. These measurements were employed about every 5 minutes during the study, after task or interaction completes. After we collected the experience data, we conducted mixed linear modeling to predict participants' overall cognitive loads. We also ran modeling separately for each subtype, which include the intrinsic load, extraneous load, and the domain load. In this model, independent variables are affect valence, which include the positive effect and negative effect, affect activation, and the working memory capacity. Random factors were subject ID and the repeated time serial. Here is the ANOVA results in prediction for the overall cognitive load. We found positive effect and the negative effect has significant effects in the modeling. Here we look at the modeling for the subtypes. We found positive effect can predict both intrinsics and the domain load, while negative effect was found to be able to predict the extraneous cognitive load. So now we know affect can predict cognitive load. Particularly, positive effect can predict the domain load, indicating that it may benefit the schema constructions. In contrast, negative effect is related to extraneous cognitive load, which is non-task related and usually should be minimized in learning. In addition, working memory capacity showed as a moderator, which was expected, And based on this connection between affect and cognitive load, we suggest that learning systems should be designed to encourage positive affect, and adaptation needed to help learners regulate their affect to enhance their learning experience. And working memory capacity will need to be considered as an individual difference when designing this adaptation. Here we look at the result about intrinsic load, which is meant to represent the inherent complexity of the learning task and should not be directly influenced by the affect. However, positive affect predict the reported intrinsic load, and this incongruity may be because self-reported scores are likely capture the perceived difficulty rather than fully reflecting the task's inherent difficulty. Based on this finding, we highlighted that data-driven alternatives are needed for assessing intrinsic load. Now we understand how affect may impact cognitive load in the game-based learning. While people use this system, they conducted rich interactions. Their learning are self-paced. And this led us to the second goal of this study: how are interaction patterns connected to dynamics of the learning experience? To address this question, in this case study, interactions were extracted from the video using gaze points from the eye trackers, and dynamics of the learner affect and cognitive load were identified, and we conducted qualitative analysis to look for potential behavioral patterns in the increasing, stable, and decreasing in these two trajectories. We found several patterns. Notably, we found learner alternated between playing and learning when affect was increasing. And here is an example from one of our participants. And they were training soldiers, then answering an independent question, and went back to play, addressing the position of the building, and right before answering another independent question. And this can happen multiple times between the self-reports. And this finding might imply alternating learning and entertainment can be an effective self-regulation strategy. And systems should support the learner's ability to recognize, understand, and manage their affect by suggesting a shift to alternative activity or providing a customizing feedback. In the study, learner can challenge other players as one of the playing elements. Yet we found learners use this peer challenge mechanism when showing declining affect trajectory, which may imply that they fail to regulate their affect. And this suggests the risk in using peer competition for affect regulation, and systems should suggest alternative activity when there is a continued decrease in the affect after the competition elements. Here's the recap of our study. Affect needs to be part of cognitive load modeling. Our analysis shows affect can predict learners' cognitive load. Particularly, positive affect can predict the germane load and the perceived intrinsic load, while the negative affect can predict the extraneous cognitive load. And we also uncovered behavioral patterns that occurred during the affect trajectories. And we highlighted that educational systems need to use this information to better support learner affect and adapt the experience to learners. Thank you.